There are two triangles we want to discuss that give us easily the six trig functions for three different angles. The one I want to look at in this video is the 45, 45, 90 triangle. So what I'm going to do is I'm going to start with a square. I can draw a square here. How'd I do? It looks pretty square. I'm going to call the side lengths all 1, because in a square all the sides are the same, and also in a square all the angles are the same. They're all 90-degree angles. Right? What I'm going to do now to make a triangle here is to take this square and cut it in half along the diagonal. Okay, and this is going to be persnickety, so let's try this again. Cut it along the diagonal. So let me just look at that, just the bottom half here. So it looks like this. I've got my right angle here. These two sides are the same as they were before. One, I can use Pythagoras to figure out what the other side is, because whatever that side is has to be the square root of 1 squared plus 1 squared, which would be the square root of 2. So that's what that side is over there. Notice that when I drew this diagonal across, it bisected this angle and it bisected that angle. So where they were 90 degrees, cut that in half, we're now looking at a 45 degree angle here and a 45 degree angle there. Okay. Look at that triangle now. I can see all 6 trig functions of 45 degrees. What's the sine of 45 degrees? Well, I'm looking at this 45 degree angle, opposite over hypotenuse, 1 over the square root of 2. What's the cosine of 45 degrees? Well, it would be adjacent over hypotenuse, 1 over the square root of 2. What's the tangent of 45 degrees? Well, the tangent of 45 degrees would be the opposite side over the adjacent side, 1 over 1, which commonly is just called 1. Right? What's the cotangent of 45 degrees? Well, it's the reciprocal of the tangent. What's the secant of 45 degrees? It's the reciprocal of the cosine. Radical 2 over 1, or just leave it as radical 2. And the last one is the cosecant of 45 degrees, which is hypotenuse over the opposite side. One thing I want to point out is that I'm very much in favor of leaving 1 over the square root of 2 as 1 over the square root of 2. You'll see a lot of trig textbooks, a lot of pre-calc textbooks. A lot of teachers tell you that you got to rationalize denominators. Back in the days before we had calculators, and if you really needed to figure out what the value of that was as a decimal, then yeah, you had to rationalize the denominator in order to be able to have algorithms that would be able to take the square root, divide. But we got high-speed calculators nowadays. Every 50-cent calculator's got a square root button, and you can type in 1 divided by the square root of 2, and it tells you what the decimal is. This is a more reduced fraction. The numerator and denominator are smaller. If you rationalize the denominator, it would look like radical 2 divided by 2. Both numerator and denominator would be bigger than they are right now. When you take the reciprocal of this, it's just already simplified. If you rationalize the denominator and then take the reciprocal, well, now you've got 2 over radical 2, and you got to simplify that. So I'm very much in favor of leaving that 1 over radical 2 like that. Do I expect that you memorize these facts here about 45 degrees? No, absolutely not. Do I expect that you can figure them out? Yes, absolutely. Because you've got this triangle. It's half of a square. Pythagoras, the square, the two sides are the same. Pythagoras gives you the diagonal. You've got everything you need. Okay? We'll use this time and again this quarter. This is one of my nice angles.